So Sai Pranav, check answers once. I'll project it. No. Pranay, Sai Shripad, check your answers all. Yeah, Pranay, one, okay, this one, yeah. Okay, nearest. Pranay, okay, yeah, fine. Some nearest here. In the end, I'll reach there. I projected somewhere during its path. Its velocities are say v1. No side strip path, not possible. See how. So here it will be. I'll bring some other place. This one. So here, if you extend this, it's a rough diagram. Here we'll take it. Now you see this. The two velocities, they are perpendicular. That's what is said. Somewhere during its motion. Hope everyone, at least you would have gone for this diagram. You are not drawn this diagram and you are giving answer means there's a big problem with your brain. I'm very open. Without this diagram and you are giving some answer to me means there's a big problem is there. Tell me like where the kinetic change, where the velocity of the speed of the object will be minimum at highest point only is asking you cos theta with this information. But we know V1. What is V1? Given V1 is 3 meters per second. V2 4 meters per second. Now you see this. We have this much. So what is the information? Is like what is telling is like they are perpendicular. So let this make an angle alpha. As they are perpendicular, so you go for a rough diagram like this. Or else this is V1. Okay, this is alpha. So this should be the condition, no? So sir, how come you can show that? Because this is 90 degrees. This 90 degrees. So this should be the alpha, no? Still not understanding. It is this the situation, no? If this is alpha, what do you expect this? -90 minus alpha. Then this should be the alpha. If that is alpha, then this is alpha. Okay. The vector diagram. Different. So what is, and we know horizontal component of velocity should remain same. So what is the equation? We can write it now, looking at this. V1 cos alpha equal to V2 sin alpha. So V1 by V2 is equal to tan alpha. But what was our condition? We have to calculate u cos theta. We know v1, v2. Tan alpha is what I obtained. Okay, let's go for minimum kinetic energy. Kinetic energy will be minimum at highest point. Here only, no? So K minimum is equal to m u cos theta whole square by 2. And as such, we know in projectile motion, what is the basic necessity condition? V1 cos alpha, V2 sin alpha should be equal to u cos theta. Horizontal component of velocity should remain same. So in place of u cos theta, I'll write it as V1 cos alpha whole square. So m V1 square by 2 cos square alpha. This will become m V1 square 2 secant square alpha. M V1 square secant square alpha, I can write it as 1 plus tan square alpha, or further tan alpha can be written as V1 square plus V2 square. So minimum kinetic energy given by this formula. I want you to, there's a one condition, like how we have range, no? Provided V1, V2 must be perpendicular. Substitute this and solve, and you'll get the answer. Around 5.7 or 5.8, it will come. We have to draw this. See, this is the 5.8 around. Okay, yeah, fine. See, this is the diagram. This, please do draw this, but don't bother this one. Huh? Don't show your intellectual ability. Put your hard work and imagination, creativity here. These things will follow once you know this one. Okay, I think this is the idea. Main part of the problem. 5.7 or 5.8 around. Exactly, I'm not sure. Approximately, I'm putting. I'll go for next one.
Sir, 1 minute, sir.
Okay, I'll wait. Completed?
Yes, sir.
1 minute.